Hi everyone, welcome to part 2 of Algebra 2, Lesson 2.8, Solving Absolute Value Equations and Inequalities. In this video, we're going to be focusing on solving absolute value inequalities. If you missed part 1 of this video, I definitely recommend going back and finding it where we talk about absolute value equations. Let's review the steps for solving absolute value equations and inequalities. So the method is that you're going to isolate the absolute value expression, rewrite the absolute value expression as a compound inequality, and then solve each part of the compound inequality. And just a reminder, in step 2, if you have greater than, you're going to write an or, and if you have less than, you write an and. Let's take a look at some examples now. Example, we're asked to solve each inequality and then graph the solution set. So what we're going to do is start with step 1, make sure the absolute value expression is alone. And in this particular case, it is alone, so I don't need to do anything for step 1. Now in step 2, I do need to separate it. So let me show you what that would look like. What I do is I copy it exactly as it is, but without the absolute value signs. Then I need to decide on a word, and this is greater than, so I write an or. Because remember, I could misspell it and say greater than, so it's an or. And then I copy it again, but I switch the direction of the inequality and I change the sign on my 5. So that's how that works. Now I'm just going to solve each one of these separately. I would subtract 1 first and then divide by 2. So let me show you what that would look like. When I subtract 1, I get 2x is less than 4. And then I divided both sides by 2, so I get x is greater than 2. Over here, when I subtracted 1, I get 2x is less than negative 6. And then I divided by 2 to get x is less than negative 3. Now, I do have to graph this, and it's really important to graph. It's also really important to have the correct word in between, because sometimes it makes a difference in your final answer. So let me show you what that graph would look like. What I did is I graphed x is less than negative 3 here. Notice the circle is not filled in. And I graphed x is greater than 2 here. Now, because it says or, I keep everything. Everything less than negative 2 and everything greater than 2. Because this is a disjunction. It means keep everything that you graphed on your number line. Let me show you another example. In this example, I'm given the absolute value of 4x plus 16 is greater than 8. So step 1 says to get the absolute value expression alone. So I'm going to subtract 16 on both sides of this. So I got negative 8 on this side. Now I can do step 2, which means separate them. So I have the absolute value of 4x is greater than negative 8. So I'm going to do 4x is greater than negative 8. Or 4x is less than positive 8. Last, I'm going to divide by 4 in both of these to get my x alone. So I get x is greater than negative 2, or x is less than positive 2. And as I said earlier, it's very, very, very important to graph this. Let me show you what the graph looks like, because if you just wrote this inequality, you might think that that is your final answer, but in this case it isn't. When I graph it, x is greater than negative 2 would graph at negative 2 and then everything to the right of it. X is less than positive 2 would graph at 2 and everything to the left of it. Notice I've now highlighted my entire number line. Because it highlights the entire number line, and this was an or inequality, it means keep everything, which means my final answer is actually all real numbers. So these inequalities were just taking me to my all real numbers answer. And that's the answer that I would need to put for this particular inequality. Let's look at another example of this. I'm given the inequality, absolute value of 3x minus 9 over 2 is less than or equal to 12. So I'm going to start off by getting my absolute value part alone, which means multiply both sides of this by 2. So that gets me this 24 on this side. Next, I'm going to divide it into 2 separate inequalities. So I have 3x minus 9 is less than or equal to 24. Now this is less than, so I'm going to write and And then 3x minus 9 is greater than or equal to negative 24. Remember, switch this sign and change this sign. So now I just need to solve each of these inequalities separately. I'll add 9 and then divide by 3. And then I'll find out what my x inequalities are. When I added 9 here, I got 33, and then I divided by 3 to get 11. So x is less than or equal to 11. Over here, I added 9 to get negative 15, and then I divided by 3 to get x is greater than or equal to negative 5. Now, this is an and inequality, so I can rewrite this as a single compound inequality. Let me show you what that would look like. I start off by writing the smallest number. Then I make the inequality sign point toward that. I put my x in the middle. Again, the inequality sign has to point toward the smallest number and then the biggest number. And notice that this is the same as these inequalities. X is less than or equal to 11, and that's what it says here. X is greater than or equal to negative 5, which is what this says. Says x is more than negative 5. Now, if you were to graph it, remember, this is an and inequality, so you only keep where it overlaps. So I start at negative 5, and I draw my arrow going in this direction. And then I start at 11, and I draw my arrow going in this direction, and I only keep the part that it overlaps. So I keep everything from negative 5 to 11, and nothing outside of that range. Let me show you just one more example of an inequality. In this one, I needed to divide by negative 4 on both sides to get my absolute value part alone. And remember, in an inequality, when you divide by a negative, the inequality sign switches direction. Now I'm going to divide it into two separate inequalities. But remember, I need to be careful with my wording. So this is a less than sign, so I'm going to write the word and in between. Now I'm going to get x alone in both of these by subtracting 3. And then I'm going to graph it. I got x is less than negative 5 and x is greater than negative 1. Now I went to graph it. X is less than negative 5 on the number line would go to the left. X is greater than negative 1 would start here and go to the right. There is no overlap, but this says and. There should be. So because there's no place on the number line where x could be both less than negative 5 and greater than negative 1, my answer is that there is no solution. That's why it's so important to look at your number line and remember to have the right word. Because if you don't do that, you might think that this was the final answer, but it can't be because it's an and inequality and there's no overlap. So there will be no solution. So I hope that helped you in your review of absolute value equations and inequalities. Please let me know if you have any questions.